We are solving one-step equations, one-step equations. You're going to see equations for the rest of your mathematical career. From 6th grade on out, all the way through all the different levels of calculus, this is the foundation for it. This is the very beginning of those higher levels of math. We're having to do a lot of equations to help us find these patterns. So we want to think of solving equations kind of like a balance beam, kind of like a scale. Both sides have to be the exact same for it to stay balanced. If I have something on one side that I don't on the other, it's going to become unbalanced. I have to make sure I'm doing the same thing on both sides. So for example, I've got this scale. If I add 3 apples on that side, right now it's unbalanced. Ooh, it's tipping to the left. So because I add 3 on the left, I also have to do the same on the other side. I also have to add 3 apples on that side. Now it's good. Now it's happy. Now it's balanced. Again, we want to keep the scale balanced. We've got 4 bananas, but now we're going to subtract 3 from one side. There they go. So what do I have to do to the other side to make sure it stays balanced? Right now it's tipping this way, this side. Oh, this way. There we go. This right side's heavier. What do we have to do to make sure it stays balanced? Subtract 3 on that side as well. That makes me want banana runs. Yum. So make sure you're filling in the blanks on your slides, your copy. Solving one-step equations, we want to solve them using inverse operations. An inverse operation is also called the opposite operation. Inverse means opposite. Inverse operations undo each other. So there's that cute picture of Yoda that says, use inverse operations to solve equations, you will. You're welcome for that. Inverse means opposite. So for example, the inverse, the opposite of addition is subtraction. The inverse, the opposite operation of subtraction is addition. The inverse operation of multiplication is division. And the inverse, the opposite operation of division is multiplication. Go ahead, pause this video quick so you can write down those inverse operations for us. Now we have a scale. Now we've got something that's a little more abstract. It's not just apples and oranges. We're representing things with variables now. So here we are still going to use inverse operations to keep the equation balanced. But now I see on the left side, I have an X and 3 of those blue circles. And if you see right there, it tells you that 1 blue circle is equal to 1. On the right side of my equation, we have 6 of those blue circles. So I'm trying to figure out what would X equal? What would be my inverse operation that I could do to make sure that both sides of my scale stay balanced? Let's write an equation to represent what we see on the scale. This is something you're going to have to do on your SOL. Take the pictures and turn it into some math. So here we see on the left side, we have an X and 3 circles, which again, each of those 3 circles represents 1. And then on the right side, we have 6 circles. So again, on our left, we have X plus how many blue circles? 3. X plus 3 on the left side. The equation means it's balanced, it's equal. And on the other side, we have 6. So X plus 3 is equal to 6. Write that down, write that down. It might be easy for you to recognize using that equation that X is equal to 3. Because if I were to take 3 away, let me write on this. If I were to take, oh no, it's not letting me, 3 of those blue circles away on the left, if I take 3 away on the right as well, that leaves me with 1X balanced and equal with 3 of those blue circles. So if you have any questions about this last part, please pause the video, ask us, check in with us. And let's go on to solving some equations using those inverse opposite operations. So our first example, we have the equation x plus 4 is equal to 12. So we want to kind of go through this thought process to help us work backwards, do those inverse operations to figure out what does x equal. So first off, I want to think what number is with my variable. And what I mean there is what is on the same side as the variable. 4. 4 is on that same side as the variable. Then, what operation is happening with that variable and that 4? Addition. Make sure you're writing down this 4 in addition. Then we want to be thinking, what is the inverse operation? Again, inverse means opposite. So what is the opposite operation, the inverse operation of addition? Division. Oh, subtraction. Where was my brain doing? Good thing I got an answer key. Subtraction. So that means to help me solve this equation, I have to do the opposite of a plus 4, which is to subtract 4. And I got to make sure I do it on both sides to keep it balanced. So I start off with my equation, x plus 4 equals 12. I want to subtract 4 from both sides. Again, keeping it balanced, doing the same thing on both sides. Fill in those blanks. So then from both sides, I need to subtract 4. Again, if I only do it on the left side, I take it away. My equation's not going to be balanced anymore. And by subtracting and adding a 4, they cancel each other out. They make a 0 pair, just like the red and the yellow circles, the red and the yellow chips that we use when we were adding and subtracting integers. A positive 4 and a negative 4 cancel each other out. And then a 12 minus 4 would be 8. Those 4's cancel each other out. I'm left with my x, and then 12 minus 4 is equal to 8. There it is, a one-step equation. It's important that we go through and we're also checking our answers. We can't always check our work in math, but this one, I can use my equation, plug in my answer to help me see if I'm right or not. So you want to start off by writing the original problem, that original equation that we started with, that x plus 4 is equal to 12. Then we want to plug in, or we want to substitute our answer. We got that x is equal to 8, so I need to take that x and substitute or plug in an 8 for it, and then see what does 8 plus 4 equal? If it's the same as 12, then we're good. And those 12s match, so that means it's going to be balanced. It's going to be the same on both sides. Take a minute, pause this video if you need to, and then go ahead and try a couple of problems on your own. Again, going through doing the inverse operation. Pause the video, and try them on your own. Did you really pause it and try them on your own? That was kind of fast. Double check. Make sure you check your work as well. All right, so on number 1, we had addition. The opposite of addition is subtraction. We need to subtract 9 on both sides. So 3 minus 9, oh no. You do get a calculator. No shame in the calculator game. A 3 minus 9 is going to give us a -6 for m. And then hopefully you went back and you checked your work. Number 2, we have j plus a -3. I don't want to add a -3 then. I want to subtract a -3. What happens if we subtract a negative? Keep, change. A double negative makes a positive. So that really turns into adding 3 on both sides. So we end up with 1 plus 3, that is equal to 4. A double negative makes a positive because the opposite of a negative is a positive. On number 3, we subtract 4 on both sides because it was adding 4. So we get g equals -16. On 4, we're adding 5. So the inverse, the opposite, is to subtract 5 on both sides. 0 minus 5 is a -5. Again, please use your calculator to help you. If you have questions at the end with these ones or the subtraction ones we're about to do, ask us at the end of the video. Check in with us then. Let's go on and talk about subtraction. Very, very, very similar thing. Again, we're doing the opposite, the inverse operation. So for this problem, y minus 7 is equal to negative 13. What number is with that variable? We've got a 7 with the variable. And what operation is happening? We've got subtraction. What's the inverse? What's the opposite of subtraction? Addition. Addition is the opposite there. So we're going to need to add 7 to both sides of our equation. Again, we do it to both sides of the equation to keep it balanced. If I only add 7 on this side's going to get heavier than that side. It's not going to be balanced. It's not going to be equal in an equation anymore. Again, if I subtract 7 and I add 7, those are inverses. Those are opposites. So they cancel each other out. They make 0 pairs. Negative 13 plus 7 is going to give you a negative 6. Again, you've got a calculator in this. Use it. Use it. So there's my answer. Again, I want to substitute this negative 6 into my equation and check to see if it worked. Again, I start off with my equation again. I substitute, I plug in negative 6 for y, and then I check. Does negative 6 minus 7 give me negative 13? And when you throw it in your Desmos calculator, you will see that it does. Again, go ahead, pause the video. Try these subtraction problems on your own, and then check back with me once you're done with all of those 4 problems to see how you did. On 1, we were subtracting 3. The opposite is adding 3. We end up with f equaling negative 2. On number 2, n minus 18 equals 2. The opposite of minus 18 is adding 18 to both sides. We get n equals 20. On 3, g minus 8 equals negative 2. Be careful with negatives. The inverse, the opposite of minus 8, is to add 8 to both sides. We end up with g is equal to 6. Negative 2 plus 8 equals 6. And then number 4, m minus 11. The opposite, the inverse, is to add 11 to both sides. 1 plus 11 is 12. And again, we check. The biggest thing you've got to make sure you're doing the same thing on both sides, or it will not be balanced. It will not be equal. If you have any questions on these practice problems with addition and subtraction, please let us know, and good luck with the rest of your day.